All right, this is problem 12-90, parts C and D. So question C says sine squared of x minus cosine squared of x equals 1 minus 2 times cosine squared of x. So, they both are kind of confusing looking, but let's look at our identity sheet, and there's anything that we already have on here that is seen in that problem. So we got sine squared of x minus cosine squared of x. If we see if that's on here at all, cosine squared of x, we have that one. No, sorry, that's backwards. We wanted sine squared of x first. So we don't have that at all, but there's something that we can do. And if we look for the other part, which was 1 minus 2 cosine squared of x, we have a cosine squared of x, but that's actually more confusing looking than what was already on the paper. So we're probably not going to use that. So what we're going to do a lot of times is actually these three ones on the bottom are kind of the most important ones and the ones we'll use the most frequently. And a lot of times we can manipulate them to mean another type of identity. So for example, in this problem we had sine of x squared. I can change this problem right here and solve it for sine of x squared. So if I do that, I'd have to minus cosine squared on each side. So I'd end up getting sine squared of x equals, if I minus this cosine to over here, I'd have 1 minus cosine squared of x. So that's something that's helpful to do a lot of times. If you don't know what to do, look at these three ones and just try to rearrange it so one of your trig functions is isolated. So I have sine squared of x is now worth this. So I'm going to replace it in the problem. So our first sine squared of x, let's replace it with what we just proved it was worth. So 1 minus cosine squared of x. And right here, this is sine squared of x. That's, again, this is just more complicated looking than it, and then we want it to be. So most of the time we're going to use these three ones that I just put a star next to. The other ones are true, but they're not as common. So I'm going to change sine squared of x to be 1 minus cosine squared of x, because we just rearranged the main Pythagorean identity of sine squared plus cosine squared is 1. So that's right here. Now we still have minus cosine squared of x. So I decided to start on the left side this time. You can do it either way, just sometimes one way is easier than the other. So we're going to try to make this right side turn into this, make this left side turn into this right side. So we have some common terms here. We have cosine squared and another cosine squared that are being subtracted. So negative cosine squared and minus cosine squared would be minus 2 cosine squareds, just like their x's, right? And that indeed is what we want this side to equal. So it equals the same thing. So we just proved that this left is the same as this right. Okay. Next, let's look at part D here. Tangent squared plus 1 equals 1 over cosine squared, of x. Okay. So again, when we look at our trig functions, we could change its tangent into sine squared over cosine squared. But let's also look and see if there's anything that's more helpful. So if we notice this trig function, tangent squared plus 1, or 1 plus tangent squared, that's worth secant squared. So let's try changing that side into that. A lot of these, so I'm going to change this side into secant squared of x. A lot of these problems, they have multiple different ways to solve it. So if you did something different, but you still got the left side as the same as the right side, it's still probably okay. And there's a lot of different ways to solve it, so that can be really frustrating sometimes. And you might have to start over. And if you do one side and it's not working, try starting from the other side and simplify that one first and change it out. So this one is secant squared of x is what this side turned into. And I can change secant into 1 over cosine. Those are reciprocals of each other. So secant squared is the same as 1 over cosine squared, and that is, what we wanted it to be worth. So we changed this left side into this side, okay? So we got one more video for the last two questions.